So today we'll be having a lecture on basic differentiation, which is included in your ASP1. Now, when you're talking about differentiation, we're basically talking about a process that is used to find out the gradient formula. So basically what happens in differentiation is that it is the process that we use to find the gradient of a point on the curve. Now, before you got into differentiation and curved equations, you were doing straight line equations. In a linear equation, you had something like y is equals to 2x plus 1, where the gradient was the same at each point of this line, right? This happens when you've got a straight line, a straight inclined line, a straight declined line. However, when you're talking about a slope like this, so the gradient in this case basically changes at every single point. So the gradient here is going to be different than the gradient here, is going to be different than the gradient here, and it's going to be different over here. Why? Because when you're finding the gradient here, you need to find the gradient at this specific point. So at this point, there's no straight line. So what you do is you draw a tangent over here and you find the gradient of this tangent line. So this tangent line is going to be different for each point. You can see that we're getting a different slope for each of these points. Therefore, you're going to get a different gradient for each point. So what you do is you apply the process of differentiation and then you basically find the gradient at each of these points. So you know that the slope of a straight line is always constant. So if you find the gradient of this slope by using the points A and B, you're going to have the same gradient throughout the slope, right? However, when we're talking about a curve, you'll have to draw a tangent and find the gradient at this specific point. So how do we basically work our way around differentiation? Now, when you're going to study about basic differentiation, we're going to be using a very simple formula, which is dy upon dx is equals to nx n minus 1. Don't get scared by this. It's basically for the function y is equals to x raised to the power of n. So if you have a function that says y is equals to x is to the power of n, then you're going to bring n before it. So you're going to multiply n before the term and then subtract 1 from n. This is going to be the differentiation formula. So if you have to write it as a differential, you're going to write dy upon dx is equals to n gets multiplied. So n times x, n minus 1, you're going to decrease the power by 1. So multiply the power before the expression and then subtract 1 from the power. That is going to be the differentiated function. Now, if they're going to ask you to find the gradient at x is equals to 2 for this specific curve, you're just going to substitute x is equals to 2 into this equation and find a constant value for the gradient. Let's look at an example and see how we can apply this. So if you have y is equals to 2x cubed, when you're finding the differential of it, you have to multiply 3 here. So 3 into 2x comes as it is, and 3 minus 1. So you're going to subtract 1 from the power. This gives you 3 into 2x square, which can be written as 6x square. So this is basically how you're applying differentiation. Now, if they ask you to find the gradient at x is equals to 2, you're just going to take this expression and substitute x as 2. So this gives you 6 into 4, that is 24. So the gradient is going to be 24 at x is equals to 2. Likewise, let's look at another example where you might have a fraction. So y is equals to 4 upon 3 x 1 upon 2. So what happens in this case is, again, you're going to multiply the power beforehand. So dy upon dx is going to be 1 into 2 multiplied by 4 upon 3x 1 upon 2 minus 1. So you're going to subtract 1 from the power. So this is going to give you 4 upon 6 x minus 1 upon 2, which is going to give you 2x minus 1 upon 2 divided by 3. So this is basically how you're applying differentiation to different expressions. Let's move forward and look at a few examples to make this more clear. So you have the basic differentiation formula given right here, and we're going to apply this to each of these expressions. So for the first one, you have dy upon dx, where 2 is going to multiply with the entire expression. So 2 into 1 upon 2 x. Now 2 will have minus 1 with it. So you're going to subtract 1 from the power. This 2 and 2 gets cancelled out. You're left with x1, which is basically x. So this is going to be the differentiated expression. Let's look at the second example. Now, in an example where you've got more than one terms involved, we're going to differentiate each of the terms separately. So I'm going to first differentiate this, then this, and then this. So dy upon dx is going to give me 3x squared means 2 multiplies with 3 to give you 6. X, 2 minus 1 is 1. Minus 4x means I just have 1 in the power, so it's just going to become minus 4. X, 1 minus 1, which is x, 0. Plus, always remember that the differential of a constant is always 0. So you just cancel it out. So you're going to be left with 6x minus 4x 0. Anything raised to the power of 0 is 1. So that is 6x minus 4. So this is the differentiated form. Let's look at the next example. So you have dy upon dx. For 4x cubed, I'll multiply 3 with 4. So 12x, 3 minus 1, that gives me 2. Minus 2 gets multiplied. So 2 into 1 upon 2 x 2 minus 1. So this is going to give me 12x squared. These two gets cancelled. We've got minus x raised to the power of 1. So let's look at the last example here. So dy upon dx is equals to 3 gets multiplied. So 3 into 4 upon 3 x squared plus 3 upon 2 will get multiplied. X 3 upon 2 minus 1. So this gives me 4x squared plus 3 upon 2 x 3 upon 2 minus 1 is going to give you 1 upon 2. So this is going to be the differential form. So you can see that we're applying the same formula to different kinds of expressions, and we're getting a specific expression for the gradient formula. And whenever they're going to ask you to find the gradient at any specific point for this curve, you're just going to put in the relevant value of x, and you're going to get the answer. Likewise, here's an example. It says that you need the gradient of graph y is equals to x squared at the point x is equals to 1. So when you need the gradient of the graph of y is equals to x squared, first you're going to differentiate it. So dy upon dx, 2 gets multiplied, x 2 minus 1, which is basically 2x. Now you have the differentiated function, and you have to find the gradient at point x is equals to 1. So I'm going to substitute x is equals to 1. I'm going to get dy upon dx is equals to 2 into 1, which is 2. So my gradient at this point is 2. This is basically how you're working your way around it. Let's look at another example here. So they're asking you to derivate the entire expression. So if we have to differentiate or derivate the entire expression, what you're going to do in this case is always remember that whenever you've got fractions, you're going to convert those fractions into a linear equation. So all the denominators are going to go up in the numerators. I'm sure you guys are familiar with the rule that an under root x basically means x raised to the power of 1 upon 2. A cube root x basically means x to the power of 1 upon 3. Likewise, if you have something like x square and cube root, then you have x square multiplied with 1 upon 3, which is going to give you x 2 upon 3. So these are just a few rules that you need to know when we're doing this question. So I'm going to take the denominators up in the numerator, and I'm going to be left with y is equals to 6x squared plus 4 upon, now let's first convert this into a fraction, x raised to the power of 1 upon 3 minus 2 upon x squared plus 1. Now we'll take this all up in the numerator. So y is equals to 6x squared plus 4 times x. Now I'm taking it in the numerator, so it's going to become minus 1 upon 3. Minus 2x, again this is going to become minus 2 plus 1. Now I'm going to differentiate this function. So dy upon dx, for the first term, I have 12x 2 minus 1, that's 1, plus 4 into minus 1 upon 3, x minus 1 upon 3 minus 1, minus 2 into minus 2, x minus 2 minus 1, plus 1. So now I'm going to, it's for the plus 1, you're not going to get a differential because the differential of a constant is always 0. So this gives me 12x minus 4 upon 3 x. Now you're going to just take the LCM here, multiplied with 3 and 3. That gives you minus 4 upon 3 plus 2 into 2, 4, x minus 3. So this is going to be the differentiated function. So here are just a few differentiation basic rules, in which the first one is basically the basic formula that we've been doing. The second one is that whenever you've got a constant, its differential is going to be 0. The third one says that when you've got a constant being multiplied, or you've got a coefficient before the expression, it's going to multiply with the power. The fourth one says that if you've got a sum or a difference of two functions or more than two functions, you're going to differentiate each of the functions separately. Don't get confused by f dash of x. Basically, when you've written a function in terms of y, the differentiated function is written by dy upon dx. Whereas when you have something like f of x and they're asking you to differentiate it, then you mostly write it as f dash of x. This is the only difference here. Here's a short summary for you guys. You can go through it. It just includes the basic differentiation that we studied today. So this is just a short summary or a précis of the entire thing that we've done so far. So next up, we'll look at a few exam kind questions and see how they've solved it. So the first question says, find the derivative of the function f of x is equals to 5x squared plus 2x plus 4. So now they've written f of x, so I'm going to write f dash of x is equals to the differential of the first function, 10x 2 minus 1, plus differential of the second function, and this is going to become 0. So 10x plus 2 times of 1, because x raised to the power of 0 is 0. Sorry, x raised to the power of 0 is 1. So the differentiated function becomes 10x plus 2. Likewise, here's another question which says, find the derivative of the function f of x is equals to 2 upon x. So the function given to us is f of x is equals to 2 upon x. First thing that I'm going to do is I'm going to take x on in the numerator. So f of x becomes 2x minus 1. Also evaluate the derivative of the function at x is equals to 3. So first I'm going to differentiate it and then find the derivative at x is equals to 3, which means I'm basically finding the gradient at x is equals to 3. So f dash of x becomes minus 1 gets multiplied with 2x minus 1 minus 1. So f dash of x comes out to be minus 2x minus 2. And you can also write it as minus 2 upon x squared. Now you have to find the derivative of the function at x is equals to 3. So I'm going to substitute x is equals to 3 into the function to find the gradient. So minus 2 upon 3 square, which is minus 2 upon 9. This is going to be the derivative of the function or the gradient of the function at x is equals to 3. All right, moving forward. So I'm going to leave you guys to do a few questions by yourself. So here are 4 questions that you can do as practice, and you'll understand the concept of simple differentiation or the basic differentiation even better after solving these.